It was 28th November 2023 when I saw this post on OpenAI's LinkedIn page wherein they have announced ChatGPT with voice. Now, it's a feature that will allow ChatGPT users to talk to ChatGPT and it will talk back, and it was available for all the free users. But the thing is, it was only available for the Android and iOS apps. And if you go to the ChatGPT on a browser, on a laptop, you won't be able to see this feature. So I thought to myself, why not build it ourselves using Python? We have all the tools, like we have a Whisper API for converting our speech to text, and we have got the OpenAI APIs for getting the ChatGPT responses, as well as converting the text to speech. So in this video, let's stitch all these pieces together and build our very own ChatGPT with voice, and we'll be able to talk to ChatGPT and it will talk back. So let's get started. If this is the first time we are meeting, my name is Mohammed Shahrukh and I make videos on coding and how you can use the power of coding to build something amazing. So if you like watching such content, don't forget to subscribe. Now, when you are working on a project, it makes sense to break down the project into smaller chunks or smaller tasks on which we can work on. So let's break down our tasks. The goal here is to be able to talk to ChatGPT and hear a response back. Okay, so the first task would be to write a code that can basically listen to our voice and then store it as an MP3 file. So what we are doing here is that we are recording our speech and then storing it as an MP3 file. And then we'll proceed to the next task, which would be to write the code to convert this speech file to text. And we'll be using the speech to text API or the Whisper API by OpenAI. Now, once we have the text from our speech, we'll then forward it to ChatGPT. Now, ChatGPT will look into the text query and then throw a response. The response will be as text. What we need to do next is to just convert this text to an audio file by using the text to speech API, and then we can just simply play the audio file that is generated. Okay, now enough of talking. Now let's get to the code. Fire up a text editor of your choice and we'll start by creating a virtual environment. We'll activate the virtual environment next. Now, as we saw in the breakdown of our tasks, there was one code that we need to write that would basically record our speech and store it as a file. And there was other part that would basically do the speech to text part. So we'll start with the fun part first. We'll do the speech to text part first, and then later on we'll build the other parts. So first of all, we'll create a file called chatgpt.py. And for this, we'll be using the Whisper APIs by OpenAI. So we'll be needing a Python library for this. We'll install it using the command pip install OpenAI Whisper. Okay, so let's start by creating a new class called ChatGPT. And this class would have a method that would give us the text from our speech. So let's call this method get text from speech. And here we'll be writing the code that would utilize the Whisper library. So let's import the Whisper library. And we need to write the constructor now. Okay, the way this Whisper library works is that it first of all imports a model, and there are several models from which we can choose from, and all these models basically differ in the speed with which they give the response as well as the accuracy. So for our use case, the model called base model would be sufficient. So we'll be using that in our code. So let's create a self.whisper model. And we need to call whisper.load model, and the model name would be base. Now we have just created the Whisper model. Now we can use it to get our response. So the response would be response equals self.whisper, and we would be calling the transcribe function. Okay, so the transcribe function would receive a file name. In our case, let's call the file name as input.wav. And we also need to supply a parameter called fp16 equals false. The reason we need to supply this parameter is that if we don't supply it, it'll throw a warning error that the CPU doesn't support this fp16. So now we have the response. Now let's try to print the response, and we will print it as this. is present in the text key, and also return the same. Okay, before we can test this method, we need to also set the OpenAI API key. So you can do this with this command. So export OpenAI API key equals to the value of your key, which you can obtain from the OpenAI's website. Now let's create a new file called main.py file, from where we will be calling this method. In the main file, let's import our ChatGPT class. So from ChatGPT or ChatGPT, now let's quickly create the main function, and we'll just simply call the main function at the end. Now let's create an object of the ChatGPT class. This is very simple if you are aware of the OOPS concept. So we are just creating an object of the ChatGPT class, and the method which we will be calling over here is the get text from speech. Now it doesn't expect any parameter. Other thing is that to run this method, you need to have an input.wav file, which we have specified over here. So let me quickly grab this file, and we will just paste it over here. Okay, now we have this file, so let's play it.
Can you tell me which is the smallest planet of our solar system?
Okay, it is asking for the smallest planet in our solar system. So let's see if it is able to get me the response. So let's run the Python main.py file. Okay, so here you can see that the output has come, and it tells me that, can you tell me which is the smallest planet? It correctly identifies the text that is present in our speech. So the part that gets us the speech from our text is done. Okay, now let's head over to the next part, where we will be calling the OpenAI APIs and getting the response as text. So we'll call it get OpenAI response as text. Now this function will receive a parameter, and it will, let's call it content. So for this, we'll be needing a ChatGPT client. So let's create one in our constructor self.client equals, and we also need to import OpenAI from OpenAI. So we don't have OpenAI installed, so let's install it. Okay, now once it's installed, let's import OpenAI from OpenAI, and now we will create our client self.client equals OpenAI. And now we can use this client to do the chat completion API call. So we'll do response equals self.client chat completions create. Now this will want some parameters, so one of them being model. We'll be using the GPT 3.5 turbo. And for messages, we'll be supplying a single message for now. The role will be user, and the content would be content. And then we'll just return the response. So the text response would be inside of response dot choices, the first choice dot message dot content. This is what we are looking for. Now this will give us the ChatGPT response from for this query from the ChatGPT API. Let's test it out over here in our main.py file. So I'll just comment this, and this time we'll call chat.get OpenAI response as text. Let's pass the query as how much is 3 plus 9. So pretty simple. Let's see what is the response that we get. We also need to print this output, print it like this. Now let's run the file. Okay, 3 plus 9 is equals to 12 is the response that we get from ChatGPT. This brings us to the third part, where we need to convert the text that we get from ChatGPT response to an audio file that we can play. So let's call it get OpenAI response as audio. So let's use the previous few methods that we wrote. So let's use the get text from speech to get the text, and we'll call it speech text. self dot get speech from text, get text from, sorry. And next, let's use the speech text that we get and pass it to the second function, which is get OpenAI response as text. And this will give us the response from the chat GPT. So let's call it now OpenAI response equals self dot get OpenAI response as text. Pass on the text that we receive from the audio file to this function. Now we have the OpenAI response, and this is as text. Now we need to convert this text to an audio file, and for this we'll be calling the TTS API. So we'll call it like this: response equals self.client dot audio dot speech dot create, and this will again receive few parameters, and one of them being the model that we need to use. For this one, we'll be using the TTS1. And next, we need to specify the type of the voice that we need for as an output. So let's use the alloy type. You can check out all the voice types in the OpenAI's documentation. At last, we need to pass in the content that needs to be converted to audio. So it is called input equals the input, and the input would be OpenAI response. Now we'll call the response dot stream to file, store the output into a file. So let's call the file name as output.mp3. And let's just print what the AI says. Okay. So now we have this part written as well, wherein we are converting the text received from ChatGPT to an audio file that we can play. So this is something which we can test right now. So let's call this method now in our main function. So we'll just comment out the previous ones, and we will call t.get OpenAI responses in audio. And so remember this input file which we have, it asks a question that what is the smallest planet in our solar system. So ideally we should get a response back that should contain the answer. So let's run this file now. Okay, so this is what I say. Can you tell me which smallest planet of our solar system? And the output from the AI is that yes, the smallest planet in our solar system is Mercury. So, and this is the output file that is generated. So let's play it now.
Yes, the smallest planet in our solar system is Mercury.
Yeah, there you have it, the output as an MP3 file. Okay, now we'll head over to the last part where we'll be writing the recorder that would record our audio. Now there are a few things that I want to achieve from this code. First of all, it should be able to record the audio, of course. Second, it should be able to play the output file which we just generated. And the third feature that I would like to implement here is that it should always listen, and it should get triggered whenever I say something. So it shouldn't be that I should press a button to record the audio. It should be automatic, just like we do for Siri and for Alexa. So let's get started. Luckily, I was able to find the exact code on a Stack Overflow answer. So we'll just use the exact code over here. Let's start by creating the recorder class. Now this recorder class will have certain methods, one of them being the record itself, and the other being listen. Listen will always listen, and if there is a voice, it will record. So let's start by implementing the listen class. So it would be basically an infinite loop, and it will call self.record. Also, I don't want it to record every time. So whenever there is a voice that is loud enough, only then we should trigger the record. So there has to be some condition which we need to work on. So if condition, only then we need to record. So what is this condition? So for implementing the condition, first of all, we need to record the audio or have the audio sample somehow so that we can do some operations on it. So for this, we will be using the Pi audio library. So let's start by installing it. So to proceed further, we need to create the input stream from which we'll be recording our audio samples. So first of all, let's create a few variables. The first being the number of frames that will be recorded. And next is the format in which the audio samples will be stored internally, the channels of the audio, and the rate of the audio. Now let's create the constructor of our recorder class where we will be creating the input stream. So we will also need to create an instance of the PyAudio class. So we'll do it like this. After that, let's start to create the input stream, and we'll specify the format of the input stream over here. After that, we'll specify the number of channels and the rate. After that, the frames per buffer, the number of frames that we need to record. So now that our stream is created, let's use it inside of our listen function. And inside of the infinite loop, let's write this line of code: input equals self.stream.read. So basically it will read from the stream the number of frames that we specify as a parameter. And we are also specifying exception on overflow as false. Now this is required because if there is an overflow of the input buffer, in that case, it won't throw an exception. So after that, let's work on the condition part. So the condition will be that we will be finding out the RMS value or the root mean square value of the input signals, and we'll be comparing it against a threshold. And if that threshold is exceeded, then we will start to record. So for this, let's write this line of code. We are storing the RMS value from a function call, and this function needs to be written wherein we'll be passing the input and it will give us the RMS value. So the condition will be RMS value. If it is greater than the threshold, then we will start to record. So and for our case, let's use the threshold as 10. So now let's work on the RMS function. We'll define the RMS function as a static method of our class, and then we'll write these 3 lines of code. So the frames that we receive from our input stream is basically represented as a string. Now it's a binary data that needs to be converted to some sort of integer on which we can perform our calculations and calculate the root mean square. So this is what these 3 lines of code does. Now, if you look into the documentation of the struct package, it is basically used for handling the binary data. Next, we'll initialize a variable sum squares, which will store the sum of all these squares. And next, we are just iterating all of the input samples. And you'll notice that we have normalized the input sample with this value. And if you Google this number, you'll figure out that this is the largest frequency that human ears can listen to. And we are just storing the sums in the sum squares variable. And after that, we are just finding out the square root of the mean. So this is the sum of squares, and we are finding out the mean, and then we are taking an under root, and we are just returning this value multiplied by 1000. Now that we are done with the RMS function, let's proceed to the record function and write the implementation of it. So we'll start off by creating a record array which will hold our recordings, and then we'll be declaring these 2 values, current and end. So the idea here is to keep recording until the value of current time is less than or equals to end. And if the value of the RMS of the input samples exceeds the threshold, in that case, we'll just push the value of the end so that it keeps recording. And then we'll start our loop with the condition, and we will be getting the data from our input stream. And this is the number of frames that we'll be needing. And after that, we are just finding out the RMS value. And if it exceeds the threshold, then we are just pushing the value of end. So when you're recording your audio and you have stopped saying anything, the recorder should continue to listen, and it should only stop listening after some duration. So that duration is the timeout length. And after that, we will just update the value of the current time, and we will append all the data that we have received into our recording array. After that, we'll just need to write the data which we have collected in our recording array, and we'll have to join the values first and then write it to a file. And for writing to file, we also have to implement a new function. So we'll call it write. So this is how we'll be calling it. And now let's work on the write function. But before that, you can see that there are a couple of imports and values that are missing. So let's do it now. So we will import struct for time and import math. And we will also set the timeout length as 2 seconds. Now let's work on the write function. So the write function will receive a parameter called recording, which will be written to the file, and we'll be opening a new file pointer, and we'll be calling the file in which we will be storing the recording as input.wav. After that, we'll set the channels for the file, and we will set the sample width, and then we will set the frame rate of the file. And finally, we'll write the frames, that is the recordings, to our file. And finally, we'll close the file pointer. That brings us to the last part where we'll be writing the player. For playing the media file, we'll be using the VLC Python library. So we'll install it with pip install Python VLC. And then we will import the library like this. And then we'll create the media player. So we will do it inside of our constructor self.player equals vlc.media player. And we need to play the output file which was generated. So output.mp3. So this is the same file which got generated from our ChatGPT. So this is the file which we need to play. And then we'll call it after the recording has completed. So self.player.play. You'll see that we have not yet called ChatGPT over here. The flow should be that after recording our speech is completed, we will send the recorded audio file to ChatGPT to get text out of it via the Whisper API. And once we get the text, we'll then send it to ChatGPT. ChatGPT will give us the text response, and then we will need to convert the text to audio file using their TTS API. So let's import ChatGPT now. So we will do from ChatGPT for ChatGPT. After that, let's create a ChatGPT object over here. C equals ChatGPT, and we will simply call c.get OpenAI response as audio. So this completes our recorder. Now, before we can proceed, there are a few checks which we need to add. First being that we should not record when the output file is being played. So we will write this line of code over here. This will check the player status, and if it is state.playing, in that case, we will not record. The other check which we need to add is in the record function. So when we are starting to record, we should not play. So we will do self.player.stop in case it is playing. So now finally, let's modify our main function and call the recorder. So we'll import it with from recorder, import recorder. We will delete all the previous code from here. We will create a recorder object, and then we need to call r.listen. Now we should place it inside of a try except block, because if there is a keyboard interrupt, we should handle that gracefully. So try except keyboard interrupt. We will print a line over here, and we will print now. It's finally time that we run our Python code and see how it works. So I'll say a short word like hey, which would basically trigger our recorder and start to record. And then I'll follow it up with a query. So let's start. Python main.py. Hey, how much is 2 plus 2?
Two plus two equals 4.
Hey, can you give me a short thank you message for my viewers, and also ask them to subscribe if they haven't yet? Keep it short and keep it friendly.
Hey there, amazing viewers. Just wanted to take a moment to express my heartfelt thanks for all the love and support you've shown towards my content. Your kind words and continued support truly mean the world to me. If you haven't already, I kindly invite you to hit that little subscribe button and be a part of our incredible community. Your subscription would mean a lot, and I promise to keep bringing you awesome content that you'll love. Thank you once again, and let's keep enjoying this incredible journey together.
And as you can see that the project is working absolutely fine and it is giving amazing results. So if you did enjoy building this tool together with me as much as I did, hit the like button and send this video to your friends. And if you'd like to see more such videos, then do subscribe to the channel, because I'll be making more such content. And the link to all of the code that we have written in this tutorial will be there in the description. Do check it out. And if you'd like to know more about the OpenAI API's new JSON mode, you can check out my other video over here. Until then, happy coding and happy creating. Thank you.